Hello, welcome back to our channel. Now we are going to discuss about previous year Eamcet problems from the wave chapter. Actually this year they said officially they are giving 70% syllabus. That's why I am focusing on stationary waves and all this. Just I am leaving that Doppler effect and all these expressions. But sometimes they are giving, take care of that. Just few problems I want to explain to you from the previous year. See, first problem is 9th September 2020 shift 1 they have given. What is the problem? See, they have given two displacements y1 and y2. y1 is what? Here y1 is the a sin omega t minus kx and y2 is the b cos omega t minus kx plus pi by 3. See these two expressions. So the question is, what is the phase difference? First thing what we should observe here, one is the sine function, another one is the cos function. So the phase difference is how much? 90. When we are going to discuss about omega t minus kx in first expression and second one omega t minus kx plus pi by 3. So the phase difference is how much here? See, we can take it. Phase difference delta phi equals to, the first thing is cos and sine function phase difference is the pi by 2. And here omega t inside the brackets, how much phase difference is there? This is the pi by 3. So we are taking plus pi by 3. After simplification, our answer is how much? So this is the 90 degrees and this is the 60 degrees. Anyway, we can take the LCM also. This is 5 pi by r. This is the phase difference between two waves. So our second option is the right, that is the 5 pi by r. Look here, our second option is right. Then we are going to the next problem. The given problem is an organ pipe with both ends open has a length is how much? 25 centimeters. An extra hole is created at position L by 2. The lowest frequency of the sound produced is, one hole they made and they are giving that, see, length of the pipe is, actually they have given 25 centimeters but they made hole at half of that one. So that's why you are taking only half of the length. Fundamental frequency in open pipe, what is the formula? N equals to V by 2L. So V value they have given in our problem, that is 340 meters per second divided by 2 into, but instead of length we are taking the L by 2 here. Okay. Half of the length we should consider, 2 cancel. So here you can take it, just length is how much? 25 centimeters. 25 into 10 to the power of minus 2. We must convert into meters per second. Then after simplification, 5 68 here. (13.6) into 10 square. 13.6 into 10 square, it should be right. 1360 hertz. 1360 hertz. So like that we have to do this one. The main logic is here, they made hole at half of the length, that's why we should consider half of the length only. Then our next problem is, the question is, see, standing waves are produced in a string. How much length is there? 16 meters. If there are, how many nodes are there? 9 nodes between the two fixed ends of the string. And the speed of the wave also they have given 32 meters per second. What is the frequency of the wave? Once you look that, the given data is, length of the pipe is how much? 16 meters. But how many nodes are there? 9 nodes are there in between that. So we can go through the simple figure also here. But the question is, we have to find out the frequency of that one. See, we are taking one fixed string in between that. Problem, they have given length and 9 nodes are there, means, so number of segments how many are there? P equals to 9 plus 1, we are taking 10. General formula for frequency, N equals to 9 into V by, this is the formula, 9 into V by 2L. but the question we have to find out the frequency. Here velocity is how much? 34. 2 into this length is how much they have given in this problem. Length is the 16 meters. So no need of converting. 16 meters. So after simplification, and here velocity is 32 meters per second. This is the 32. 32 cancel, and here number of segments are 10. We are taking the 10. So answer is how much? N equals to 10 hertz. The question is in between that these two, how many nodes are there? N nodes are there, means how many gaps are there? 10 segments are there. So that's why you can take it. P value how much? 10. So P into V by 2L. Given data we are substituting. Then N equals to, we are getting 10 hertz. Then our next problem is, look here. See this. A string of length 100 centimeters has 3 resonant frequencies 120, 200, 280 hertz. If a node is formed at the end of a string, the speed of the transverse wave on this string is. How to find out the speed of this one? First of all, you see this, a string is of length is how much? 100 centimeters, has 3 resonant frequencies 120, 200 and 280. So what is the common factor in this? 40. Okay, 43 ja, 45 ja and 47 ja. So common factor we are taking, that is nothing but fundamental frequency. So N is the fundamental frequency. Common factor we should take it. N equals to 40 hertz. But they are asking about the speed. N equals to, what is the formula? V by 2L. V by 2L. From in this N equals to how much? 40. Here 2 into length of that one is clearly they have given 100 centimeters. When we are converting, it is the 1 meter. This is the 1 meter. Look here. This is 1 meter. We are substituting. N is the 40 hertz and this is the 2L. L is the 1 meter. Finally answer is how much? 80 meters per second. 80 meters per second. So like that we can find out the thing is resonating frequencies. From the common factor we can able to find out 40 hertz is the common point. Then our next problem. The question is, they have given that two identical, look here, two identical sinusoidal waves are there. It's looking very lengthy, but nothing is there. Here the phase difference is clearly 120 degrees and two waves are having the same amplitude. Resultant also they have given 2 millimeters. So the given data is only two things. One is the angle between them is the 120 degrees phase difference and the resultant amplitude is how much? 2 millimeters. The question is, what are that individual amplitudes? It's very easy, no need of doing that. From the parallelogram law of addition of vectors, if phase difference is 120 degrees and here A1 equals to A2 equals to how much? That is the, we have to find out. But resultant amplitude is how much? They have given that 2 millimeters. So resultant, what is the formula? Under root A square plus A square plus 2A square. Cos 120 is how much? Minus 1 by 2. So the question, this is like this, and when we are doing the simplification, this one cancel, minus A square cancel. Resultant under root A square is nothing but A. Resultant, they have given R value 2 millimeters. So amplitude is how much? 2 millimeters. Without doing this calculation also you can express that whenever the phase difference is 120 degrees and resultant is same, in same individual amplitudes. Then our next question is, see the speed of the sound wave. The speed of the sound wave is how much? V at a temperature T. Then what happens? Then the temperature is increased to 2 times. Then what is the velocity? So what is the relation between temperature and absolute velocity and absolute temperature? V is directly proportional to absolute temperature. So V1 by V2 equals to what we are taking? Under root T1 by T2. Clearly they have given V1 value is the V by V2 equals to under root T by 2T. In IPE also, kinetic theory, we are having this problem. So here finally we require the V2 means answer is how much? Root 2 times of this V. So they have given in our problem pressure also, but no need of considering, just we should consider the temperature and velocity relation. Thank you everyone. Please subscribe my channel.